Okay, let's look at our big ideas. What do you guys think? You see? Okay, let's hear it. Sydney. Good. 1 out of 5 plus 4 out of 10. Well, they're not the same, right? Right? So what do we have to do? Okay, can I get people to raise their hands, please? That would be great. All right, Dina? Okay, let's not use math terminology whatsoever, even though I always like you to, but in this sense, I don't want you to. But that's, you're using, talk like a kindergartner to me, yes. I need a bigger circle. I can't make a bigger circle. Cut more slices. You see what I'm trying to do? So cut more slices. How many more slices do I have to cut? Or couldn't I just make each one of them bigger by 2? That's not kindergarten math? Okay, so I'm cutting it in half. Good. So the whole point, guys, whoa. You guys have, it's like you had Kool-Aid before you came in. I know, okay. That reminds me, we should have Kool-Aid Fridays. That would be fun. Okay, 5, 4, 3, 2, 1. Okay, so if I look at this using math, it looks like this, right? 1/5 plus 4/10. I need to make this bigger by 2. I'm going to multiply by 2 over 2. And then I'm left with 2 over 10 plus 4 over 10 equals 6 over 10, right? But now I need to reduce by 2. So I'm going to reduce 6 by 2, which makes 3, and reduce 10 by 2, which makes 5. Which brings me back to, did I have to cut this in half? No, I could have done this. I could have done this. Let's see, ungroup it. It worked in the last presentation. Oh, because I was using my old, oh, there it goes. Instead of making smaller slices, I made bigger slices. Couldn't I have done that from the very beginning? Couldn't I have simplified 4/10 to make smaller, right, a smaller denominator? Okay, so there's more than one way to skin a cat, okay? Okay, all right. Remember, good. All right, so these x's can't possibly be equivalent. Why? Raising your hand. Let's hear it. Yeah, if that x was 5, does that mean you'd take that one that's also 5? Would you say, oh yeah, that's equal to 5 too? No, you'd be like, I just got chips. That's a smaller piece of pizza. Right? So, I would have to, right, cut this one and make sure these are all x's. Now we've got equivalent x's. Or I could have combined these and made it just one x here, right? We could have done either one of them. So my whole point of that was that using variables in there, it's the same thing, right? So I would get 6x over 10x, 6x over 10x, which reduces to 3/5. Okay, so there's our big idea, our whole conceptual way of looking at it. All right, fractions equivalent to 1/3. So can somebody give me a fraction that's equivalent to 1/3? Let's hear it. 2 over 6. What'd you do? Multiplied, but not just by 2. You actually multiplied by 1. Right? Stina. 1/3 is equal to 4/12. How'd you get 4/12, Stina? No, you multiplied by 1. 4 over 4, right? Whatever. Why are you guys all upset by that? I don't understand. You love it? What if I wanted to make it, what if I did this? What did I multiply by? I multiplied by 1. I multiplied by 5x over 5x. I can't believe how amazed you guys are. Like, you're so easy to please right now. We got a bigger number by multiplying by 1. Exactly.
Not 1, 1 more. No, not the number.
It is 1. It's 1. It's 1. Okay. I did not expect this phenomena. Okay. So, x plus x over x plus 1. Couldn't I do the same thing? Let's make it bigger. Which I'm not really making it bigger. Right? I'm just making it more complicated. You don't get it? How does it work? It's like unsimplifying.
One-third is a fraction. 1/3 is a piece of 1.
No. Okay, whoa. Okay, so they're almost going to fight right now. Okay, let me intervene. Okay, so I know. Let's stop recording. Okay, so let's explain. Everybody be quiet. Okay, Philip, explain your case.
Okay, I'm saying this.
Uh-huh. I'm not making it any bigger. It's not getting any bigger. It's still 1/3. I just made it, I unsimplified it. So, because, Philip, if you saw this right here, if I had this right here, what would you do? You would divide both of them by 2, and you would get 1/3. I have the same thing, I'm just making it more complicated. Hold on, guys. I got to ring you in. Okay, I know you're all excited with your newfound understanding, but we got to move on. All right, so x over x plus 1, if I multiply that by, what do you guys want to make it bigger by? 6? It's not bigger by 6, though. It's bigger by 1. There we go. Okay. So now it becomes 6x over 6x plus 6, and it's still equivalent. Can you cancel out the thingy? If I cancel out the thingy, it'll be this again. Right? Yes, Dina. It's like you guys don't believe me. Dina? Can I please restate it? Okay, I need you to stop talking, Kayla. Okay? Can I restate it? I'm multiplying by 6 over 6, which reduces to 1. Right? So I think you guys are getting hung up on what I'm doing is I'm doing something in reverse. Okay, I'm trying to show you where simplifying comes from. Okay, I think we just need to get into the lesson. Okay, I really do. Okay, all right, really quick, let me hear it. Oh, yeah, it's true. Yeah, it's just more slices, but it's still the same amount. That's a really good way of looking at it. I like it, Dylan. Right? Yeah, I like it. I'm not going to draw it, but I like it. Okay, let's work on this really quick. Rewrite the expression 2x minus 3 over 5, 2x minus 3 over 5, to be equivalent form that has an excluded value of x equals 4. So if something had an excluded value of x equals 4, what did it used to be in the denominator? It used to be x minus 4. So if I want to make this have an excluded value of x minus 4, I can't just go, oh, okay, done. What do I have to do? I have to put x minus 4 in the numerator because now I'm multiplying this rational expression by 1. Right? So it's not changing, it's just unsimplified. It's getting more complicated, right? It's got more factors, but it's still worth the same amount. It's got more stuff. It's just like if I've got a 10 and I want ones, right? I still have $10. I just exchange it for ones, 10 ones. It doesn't make more money, right? It just changes the form. Okay, so why don't you guys do this one on your whiteboards for me really quick? Oh, I'll finish this. No, I'm not. I'm recording. All right, so I have rewrite this expression, which is x plus 7, to have an excluded value of x equals negative 1. It's like we're working in reverse, right? So that would be an excluded value of x cannot be negative 1. So that's what we need to multiply in our numerator and our denominator. So all you have to do is just put this over 1. So this equals x plus 7 over x plus 1 over x plus 1. Make sense? Okay, let's keep going. All right. Adding rational expressions. So let's use numbers and then compare them to applying it to Algebra 2. All right, so if I have 1/2 plus 1/4, I don't have the same thing in the denominator. I don't have common denominators, right? So I have to make this one multiply by, I'm going to use, 2 over 2, so that it can become 2 times 1 is 2 over 4, plus 1 over 4 equals 3 over 4. All right, so I'm going to do it to my Algebra 2 now. Okay, so I can't really compare them yet, right? Because this one doesn't look like it's in the same form. But I recognize that this is the difference of 2 squares. So I'm going to rewrite it as x plus 5 and x minus 5. And I'm going to add it to 1 over x plus 5. Let's recap what I just did. Let's summarize the step I just did. What did I do? I factored. That's it. The first thing we do. The second thing we do is we want to state our excluded values. Because we have some now. Excluded values. So what are my excluded values there? X cannot equal negative 5, and it can't equal positive 5. Because if this was positive 5, that would make this 0, and that would be undefined. And if this was negative 5, that would make this 0, and it'd be undefined. Okay, let's continue. All right, what is this one missing that this one has? This one's missing x minus 5. So I need to multiply it by x minus 5 over x minus 5. I'm making it more complicated so that I can combine, so that I can add my numerators. They've got to match on the denominator before you can add, right? Like this one, right? I couldn't add those two. They're different. This was a half a pizza and this is in fourths. So I had to cut the half of the pizza in half to make fourths, right? I have to do the same thing over here, right? Okay, so plus 1 over x plus 5, x minus 5. Devin, is it helping the second time? Good. Good, good, good. Awesome. All right, so that was equivalent expression. Now here's another equivalent expression. X minus 5 times 1 is just x minus 5 over x minus 5, x plus 5. I normally wouldn't do this extra step, because right now I can look at it and I can see that they're the same, right? And if my denominators are the same, I can combine my numerators. It's like baskets of we said boxes of cookies. This one has boxes of cookies, this one has boxes of cookies, so let's add up how many boxes of cookies we have. Okay? So, but for this example, I'm going to go ahead and make sure I do all my steps. But normally I would skip this one right here and go straight to this. Okay, so equals, I've got an x, I've got a negative 5, and a positive 1. All over x minus 5, x plus 5. I hear whispering behind me. So now I'm going to combine. I've got an x, a negative 5, and a positive 1 make negative 4 over x plus 5, x minus 5. That's that. There's nothing else I can simplify. We've combined everything. If it was something that I could factor, and then I could possibly cancel, right? All right, so when we get to this point, it's like your multiplying and dividing worksheet, or no, the simplifying worksheet that we did, right? Okay, so let's go back and make sure we have all of our steps down. So we stated excluded values, then what did I do? Can you put it into words? What did I do next? I stated my excluded values, then what did I do? I multiplied by 1, or I found my common denominator, right? Common denominator, and we did that whole thing. Then I what? Once I had a common denominator, I could combine like terms in the numerator. It is so easy, right? It's not complicated. It's just using algebra, right? But it's ultimately it's 4th grade math in essence with algebra. Okay, and then finally we would simplify. Simplify if we need to. Okay. Does anybody want to take a picture of this before it'll be on Schooloom. You're like, look how happy my teacher is. Okay. All right, I don't think we need to do a subtraction one. It's the same thing. So let's get right into, quickly, how much time do I have? Take a minute to look at it and talk with your table group about all of these are wrong. Okay, I'm going to give you guys a minute. I'm glad you're upset. This is how math teachers feel. We go, what? We see stuff like this.
Really?
We made these up on what kids do. Okay, so this one the person decided they were going to cross cancel across a plus sign. That's not right. This one they decided they added the numerators, but then they multiplied the denominators. That's not right. Yes.
Oh my gosh.
2 plus, okay, so this one they added this is the most common one. They added the numerators and they added the denominators.
Okay, that's kind of easy.
Yeah, I can see where they came, but you can't do that, right? That's a no-no. And this one, yes, we see stuff like this, you guys. They decided they're just going to multiply everybody. Okay? All right. So instead, let's show what they should have done. Okay. So they should have gotten a common denominator, right? This is an x. This is a 3. They don't match. The x needs the 3. And the 3 needs the... So now I have 3 times 2 is 6 over 3x, plus x times x is x squared over 3x. Now I have common denominators, so now I can combine my numerators. 6 plus x squared over 3x. Then I'm going to do this. Can't do that. That's another common mistake, right? Can't do that. Okay. I think you guys are going to do good. All right. So here are our steps. I'm not going to talk about that right now. Okay, so this is a perimeter. It says find the perimeter. Can you show me with your hands what perimeter is? I like it. I like it. This, right? Okay. All right, so that's the perimeter. Show me what area looks like. Oh. Devin did what? That's area, right? The whole inside. Okay, very dramatic. I'm not going to do this one because it's long. Let's just talk about what everybody needs. Oh, yes. So, listen, this one and this one match. This one should really be x plus 3, x minus 3. This one sort of looks like this one, but it doesn't. This one could be, like if I change the order of them, it looks like this. So I'm going to take a negative out. Double check that I'm right. Negative times x is negative x. Negative times negative 3 is positive 3. So this is correct. So I could have changed this right here to negative 2 over x minus 3. That would be, this is equivalent to this. So basically now, all of them, the only thing they need is this one needs an x plus 3, this one needs an x plus 3, and this one needs an x plus 3. Then I can combine all the numerators. Okay? But we're not going to do that one because it's long. Same thing with this one. Right? I'd have to switch this one. Right? Factor out a negative. Then these two would match. And this one is x plus 5, x minus 5. So these both need an x plus 5. Yes. I'm sorry. Sorry. Okay. So this is number 8 on your homework. Okay? So I'm going to do number 8 really quick. Unless, do you guys want to start? You think you're ready? Okay. All right. So I'm going to have you start it, and then I'm going to give you about, 2 minutes to do this one, and then I'll do it for you? All right. It seems like I need one more. No? Let me just look through here and make sure. Oh, what would I do with that one? All right, if I want the same common denominator, I just got to create one. Yes. Like borrowing? Like regrouping? No. Not with this. Okay? Because it doesn't work when you've got algebra. But I understand what you're talking about. Okay. So if this has a denominator of x squared plus 3, and this has a denominator of 1. This one needs a 1. Well, it really already has 1, right? Always. And this one needs an x squared plus 3, so I just multiply the numerator and the denominator by exactly what I need. Okay? What about this one? What's this one going to, show me on your whiteboard what this one is going to need. Not this one. What's this one going to need? Just show me what you're going to multiply by. That will give me a good assessment of what you guys, not on your desks, I want to see it. Real quickly, what is this one going to need in order to create a common denominator? Okay, show me. You either know it or you don't. Show me. Here, here, here. Good, 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 good. I think we're 100%. Awesome. I would multiply this one by x minus 2 over x minus 2. You guys are ready, yeah? Okay. Ooh, what would I do with that one? Not simplify, but factor first. You guys are ready. Okay. Good job. Let's see. What's the first one? Did we do? I can do number 4. You need number 7? Okay, I'm going to do number 4 and then I'll do number 7. Yeah, those answers are always on School Loop. Here's number 4. X plus 4 over, I'm going to factor x plus 2. Why is there talking when I'm talking? And then I'm going to factor my numerator 2 times. I'm not going to factor it yet because I'm going to need to combine this, right? So I might as well just leave it right now. Okay, and so this one, so 2x plus 2. I could have, but then I would have just been making more work for myself. And this is x minus 2. X plus 2. Don't they already have common denominators? Yes. So we just have to combine the numerators. So x plus 4 plus 2x plus 2 all over x plus 2, x minus 2. X and 2x make 3x. 4 and 2 make 6. Over x plus 2. You guys, I'm talking and I'm recording. X minus 2. So now I'm going to factor out a 3, which is 3 times x plus 2 over x plus 2, x minus 2. And so now all I have to do is, what are my excluded values? X cannot equal negative 2 or plus 2 because that's now a whole, right? And now my answer is 3 over, what kind of graph is that? Good job, rational function. Okay, I'm going to go ahead and, I need to pause it.